All right, so any other questions? That was just up for humor value. That was not a policy statement in any way. Questions about what we covered last time? Anything? Okay, project 4 is posted on my web page. I will get it linked into Blackboard when I get a chance this afternoon. But if you go and look, you should be able to find it. Oh, I forgot to link it to the index. So if you click on like project 3 and then you go up to the URL at the top and you change the 3 to a 4, you can see the project now. Sorry, I was up late doing it and I didn't finish linking everything up. But I will do it right after class so you can go take a look at it. Yeah? Yes, questions about last time? Mm-hmm. Yep, so we talked about last time, we talked about classes. They have 3 different categories of things. They have public, private, and protected. We will not deal with protected this semester. Just be aware, don't forget if you see it. Public means that you can do something like this, like leon.getAge, right? Leon is an object of class person. Because getAge is declared in the public portion, you can call that, okay? In fact, let's compile this and just make sure I haven't made some sort of gross error. Okay, so if we run this, we get that. If we try to put something in the private portion down there, like if we just say leon.age, right, like this, age isn't a function, it's a variable, but it's actually a private data member in the class person. So we can access it just by doing dot something, right? We don't need a function call. And if we try and access age, if we try and compile it that way, what you will see is that this error age is a private member of person. So you can't just access things that that are private. But things that are inside the class can, right? Like get age, wherever that was right here, can just return age because it's defined in the public portion. So, Kevin. Okay, so what's not clear, because we're making some small examples, is why you would actually do this, right? One of the things you might do is if we made age public and we just let anybody access it, that means they could write to it, they could read from it, they could do anything they wanted to it. What we can do, and what we sort of did in this case, right, is the only way to change it is to go through this function we called birthday. And the only thing that you can do by birthday is make it grow older. Does that make sense? So by keeping that in the private portion so everybody can change it, and then writing our methods can make sure that the stuff that's stored in the private portion only gets changed around in a way that makes sense in the context of the program. Does that make sense? So it's kind of like, you know, I really keep coming back to the bank analogy, right? Like everything behind the bank tellers, behind the bulletproof glass is private, and then the interface is the teller, and you have to ask the teller to go back and get stuff because you don't want people wandering around and, like, you know, stealing money, I guess, is what you do if you get behind the window there. So, or stealing deposit slips. I don't know, whatever you do if you get behind the window. Other questions? I saw a couple of hands. Did that answer your question? Okay. Yeah. Okay, so the question is, access and observer methods, should they always be public? Not necessarily. It depends on the context of what you're doing. Also, you don't necessarily need to have accessors and observers for every single thing, right? Like there are some private data members that are literally private. Like you don't have, and you may not want to have a way that people can get at those things. It all depends on the context of what you're doing and how you structure your class. It also depends on how lazy you are. So I'll just tell you, in C, every single accessor and observer that you want, you actually have to go and type out, which is really annoying and time consuming because it gets completely boring. You're like, get age factor, set age, and you do that like 20 times, right? And then you quit computer science because it's just way too boring. Other languages that are kind of more modern than C, when you have a class, they will actually automatically create all the accessors for you. You can literally just kind of be like, yeah, make an accessor for this one. And because they're all the same, right? And you can just go ahead and do that for you. So some languages are a little bit easier to work with. Yep. Nope. If you had a private method, you would not be able to call it from int main. You would only be able to call it from something that was public. So when you look at the project 4, you'll notice there are some private methods, and they are methods that are intended to make it easier. So I'll just describe project 4 for you briefly. It's sort of like project 3, right? You are going to have a list of groups of subjects. At this point, they have all been given the inoculation for the RSV virus, and they're doing follow-up study. So you will have a file that looks a lot like the project 3 file. The format is exactly the same with one addition, and that addition is that group code that we added from last time, whether they're ineligible in the experiment group or control group. Okay, so we have files that look exactly the same with that code. A second file has side effects, like a test to see if there were side effects to the vaccine. The other file has 4 entries. It's got the subject ID number, which will match one of the subject ID numbers of the experimental group. It has a factor related to their stool factor, a factor related to coughing, which relates to their asthma, and a factor related to headaches. And these are just kind of arbitrary. They're not scored exactly the same way as they were before. Okay? And so they have kind of these side effects. And so what your job is going to be is to write a program. The first thing it does is it says, please tell me which subject file you're using, and you'll load the subject file. The second one says, please give me the side effects file. And what it will do is it'll load the side effects file. And the way it loads the side effects file is it looks at the subject IDs, and it finds the matching subject ID and adds the side effects to a particular person. Okay? And then what ends up happening is it does a statistical analysis to determine if there's a difference between the control and experimental group for different categories, right? For the headache, for the stool, and for the coughing. All right, that's it. It's simpler than last time. But the way we're going to be storing the data inside is that we are going to have a subject class. And I've given you the definition for the subject class so that you don't have to write it yourself. It is similar to the person class, except it has more stuff inside of it. Okay? There's also what's called a trial class. And the trial class is going to be a class that has within it a vector of subjects, which is where we store all the subjects that we've loaded. And it has the functions that do the analysis. So there is a function that says do headache analysis, there's one that says do cough analysis, there's one that says do stool analysis, but there is also in there a private function that I can't remember the name for. It's like average for group and standard deviation for group. These are private methods that cannot be called from outside, but your get headache analysis can call them because they're all doing the same computation, so we abstract it into one place. Okay, so that's kind of the overview of the project. It should be easier than last time. Unless you want it to be harder. You don't seem excited by it being easier, so no. Smirking. I don't know. I don't know how to read you today other than I might be at grave personal physical danger right now and should be ready to run. So so that's the project. And so take a look at it. I'll make sure I link everything correctly today. If you want to look at it right now, bring up project 3, go up to the URL on the top, replace 3 with 4, and you'll be able to see it. Also, you'll be able to run it out of my account. I just forgot to put that in the assignment, so I have to clean up the assignment today. Questions? Yep. Okay, an observer tells you what a value is. So in this case, get age would be the observer, because it lets you see. The accessor allows you to change the value. So in this case, birthday would be the accessor that allows you to change the value. It only allows you to change it in a sane way. The other thing about these accessor functions is you can do a lot of error checking in there, right? Like this is the place where you can say, oh, you know, if we really wanted to do something, like we only have one accessor, and this is kind of an unusual one, right? I'll show you another example today. But you can do error checking in the accessor to make sure that you're not doing something crazy, right? Like if we had something that just said set age instead of birthday, right? You would say, well, age can't be less than 0, and if you're getting above 120, something is probably fishy, right? So you could throw error messages there and do error checking in your accessor before things got set into the object itself. Okay. Everybody good? Let me ask you all a question. What is a class? A blueprint. What is an object? Okay. When I say class, you say blueprint. Ready? Class. When I say object, you say thing that is instantiated from blueprint. Object. Perfect. Thank you. Okay. So just to keep those two separate, because that's like confusing at first, right? When we say classes, we're actually talking about this outline and layout. And when we say object, we say the thing we have built that conforms to that blueprint. Okay. So, all right, any other questions? Good questions so far. Should we talk about some other stuff? All right, so I brought up the code from last time, and I wanted to show you one more thing. So we have a person class, and we've seen how we can kind of just use these person objects directly by setting them and things. But I would like to show you how we can kind of put these objects inside other objects. Okay? So Leon and Bob are both 12 years old. What kind of activities are they likely to partake in that they would be together in some sort of peer group? Yes, sir. Recess. Okay. So here we're going to go. We're going to have a recess class. And recess is going to be a class that contains information about all the people, in this case, younger people, who are on recess. It's not where I expected this to go, but I like it quite a lot. So, all right. So if we have recess class, we will have some public portions of it, and we will have some private portions of it. And how might we keep track of a group of people who are at recess? What do we know? What kind of thing do we know can hold other objects? Yeah? A vector of person. So can we do this? Can we just say vector person? How many of y'all think we can? How many of y'all think we can't? How many of you have suffered arm injuries in the last couple of weeks? Some people have really suffered arm. Just nobody wants to raise their hand. Okay, turns out you totally can do this, right? Once you have defined a class, it is just like any other thing. It's like an int, it's like a float. In particular, it's like a string, right? A string is already a class. And a string has inside of it a whole bunch of characters, and it has methods that tell you how long it is and what letter is where and stuff like that. That is exactly a class. All right, so we can use a vector of persons, and I think over here I'm going to have to add pound include vector, because we're going to need that. So we can have a vector of persons, and what do you want to call this? We'll call this like the kids at play. Okay, so our recess class is going to have inside of it a vector, kids at play. And we're going to be able to store kids inside of that, okay? All right, everybody with me so far? Okay, so here's what we do. We need to add some methods. We can have a method that says go to recess. And this will be void, because we won't do anything. But we need to have a person to add to recess, right? And we might have another one that says leave recess, or go back inside. What do you want to make it? Everybody is eager to shout out suggestions. So, okay, we might have other things like, let's do these first, and then we'll take a look and see what other things we need. All right. What I'm going to do here is I'm going to delete some of this old stuff, though, because we won't need all this for a while. Okay. So we have a couple of methods. We have a private data structure. What is go to recess? What kind of method do you think that will be? I'll give you some choices. Constructor, destructor, accessor, observer, or iterator, even though we won't do iterators. Those are all your choices. There's 4 of them. It will be an accessor because it will allow us to change the value. So here's what we do. Oh, we also need a constructor, don't we? And here is our recess constructor. And it does literally nothing because we don't have to have it do anything. There you go. Is that useful? The default constructor that does nothing? Yes, I do need 2 semicolons. Thank you. Here? Yes, I do. So here, who would like some candy? You tired of Twix bars? So here's the problem: is I've been writing the autograder in a different language that doesn't use semicolons. So I'm used to not using semicolons. Okay, so we have a recess constructor. It doesn't do anything, and it doesn't do anything because we don't need to initialize anything in there, right? If we needed to make some changes to this vector, this would be where we did it, but we don't need to do anything. So, all right, we need a void recess. This means it's part of the recess class. It's called go to recess. And this is going to take a person as an argument, and it will be one of the kids who's at recess. Do you wish you were at recess, Nate? Is that why this came up? So, I sometimes do. Okay, so what are we going to do when a kid goes to recess? Yeah, add them to the vector, right? So all you have to do is kids at play. Uh-oh, I'm coding myself into a corner here. Dot push back kid. Pretty easy, right? Kid goes out to recess. We're keeping track of who's at recess in this vector. Someone comes out, we just add them to the vector. We're good. Why are you all looking at me with smiles like that? Do you know what code how I've made a mistake here? All right, so let's just go ahead and compile this and make sure we haven't made any gross errors yet. It's good to compile as you go. All right, that's nice. And what we can do down here is we can start testing our code already. So what I'm going to do is I'm going to create a recess object. And what will this be called? The playground. Okay. So I create a recess object named playground, and we can have who's going to recess first, Bob or Leon? Bob gets out first, and so he joins the playground by saying go to recess. Okay. Everybody with me so far? Seriously, everybody with me? Who's with me? Who's against me? All right. I pay him to do that, by the way. All right. So here we go. Let's see if this compiles. Let's see if it runs. It does. It works perfectly. We just have no idea what it did because we haven't done anything to give us any output, have we? So you know what would be nice? If we had a who is at recess class. And would this be an accessor or an observer? Okay, so let's code this up. We say void, I belong to the recess class. My name is who is at recess. And what does this function, this method have to do? How do we know who is at recess? Yep. Okay, how do we output what's in the vector? The size is part of it. Yep. Iterate through it and show the name. So how do we iterate through it? For loop int I equals 0. I've been typing for loops like this an awful lot recently. I less than kids at play dot size I plus plus. And then we just say who, we say kids at play is the vector. If I just didn't put spaces in there, I dot what? Get first name. Because we already have that one written. There we go. So now, down here, after Bob goes to recess, we can say playground dot who is at recess. Just like that. Yep, am I missing something? Question. Well, let's make sure this works first, okay? and we'll take a question. So it compiled cleanly, and we run it, and something horrible happened there. Yeah, Cout would help, wouldn't it? Thank you. You knew that was coming too, didn't you? You were just waiting for me to screw up. It's fine. I see how it is. Because this needs to return. Oh, we need to put the Cout here. Sorry. You knew I was messing that up too, and you kept it from me. All right, everybody with me now? So who is at recess is an observer function, and what it does is it iterates over the kids at play vector, and for each one it calls the get first name. So kids at play square brackets I says look in the vector, find one element of the vector. What type is each element of the vector? It's a person, right? So the vector is a people. So when you say kids at play square bracket I, where I is a reasonable value, it looks in the vector, it finds one particular person in the vector, and then it says dot get first name. Well, get first name is actually part of the person class. So for that element in the vector, it will find the first name, and it should output it because we have Cout now. Okay, I'll step through this again one more time in just a second, because this stuff is a little bit weird at first. Oh, shoot. Okay. And so we run it. Robert is at recess. Okay. Now you're saying, why did it say Robert? Because if you remember, when we created Bob, his real first name was Robert. Okay. All right, everybody with me so far? Yes, sir. What is an object? It's an object that we just created. It's of class, playground is of class recess. With me so far? See, this is kind of, like, I'm not sure today if you all are being quiet because you're completely baffled and nobody is willing to admit it, or if you completely understand it and I can go on and do other stuff. But thank you. Thank you. Who else is now willing to admit that they're kind of baffled? All right, thank you. Class goes a lot better for you if you're honest with me. So let me just step back and we'll talk about what we're doing, okay? When people think about programming, we have to program in a way that makes sense to us as people, right? When we think about problems, we don't think about problems in terms of big blocks of memory with stuff stuck in random boxes that we have to go do stuff with, do we? Like, is that how you normally think about your day? Right? Because if so, then you are probably some sort of robot, okay, instead of human. That's not the way we work. The way we work is we think of how things relate to each other, okay? So the idea behind this class structure is that we're able to structure problems into things that we can sort of think about, okay? And we're able to structure problems in a way that these things we think about relate to the computer in that they both have data specific to the thing they're thinking about and functions combined together that allow us to work with this thing we're thinking about. So in the thing we're doing here, we're thinking about some kids, and we're thinking about kids going to recess. Okay? Kids are people, so we have a person class that describes the things that we need to know about the person. First name, last name, age, name, height, weight, right? And these are just arbitrary. You could put other things in there depending on your problem and depending on what you need to know about people. So now we have this idea of a person, okay? Does that make sense so far? We have this person, and this person is an object. It's a model of a person, really. It's not really a person. It's a model of a person. It has an object, and we can relate to it in that we can ask it its age, we can ask it its first name, we can tell that it gets older through its birthday and stuff like that, okay? Everybody with me? Is that better? Yes? Who's still sort of confused about that? Everybody close their eyes. Close your eyes. Close your eyes. I'm not going to, right. Now raise your hand if you're still a little confused. Okay, put your hands down and then you can open your eyes again. There, now, no embarrassment, okay? So people are starting to get this a little bit, but the idea is this, is that we can model things in our heads and in our programs in a way that we can think about more easily, okay? And the way we do that is we make these little models of things. So this person class is a model of a person, and the only things that we have to model are the stuff that we're interested in for the purposes of this program, their age, their name, stuff like that. For the purposes of the program for Project 4, we'll be modeling different things. We'll be modeling their subject ID, age factor, yada, 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 and then what the side effects that were observed after the vaccine were given. Okay? But we're combining these things all together into one thing. Yep. Okay, so what is a class? And what is an object? Exactly. So let's try this. Let's step through from int main, okay? So let's just start at int main. Okay, we say int main. What do we do next? We go down. We see person Bob. Well, that's interesting. Person Bob. How do we know what a person is? How do we know? Exactly. We have this class person up here, which is this model of how we're thinking about people. Okay? Just like we declare any other variable, we can what would int Bob be? If we had int Bob, what would that be? If we had double Bob, what would that be? If we had I'm not going to say float Bob because I don't want to give you the opportunity to make a joke about that. But say we had bool Bob, right? Like we declare variables just by saying the type and then the variable name. If we said string Bob, what would that be? We would have a string named Bob. Now we say person Bob. What do we have? We have a person. But what constitutes a person? How do we know what's in a person? Because we're instantiating this blueprint. So when we say class person up there, that doesn't create a person. It just tells you when you do create a person, what it's going to look like. And the way we create the person is the same way that we define any other variable. We just put the type and the name. You look happy? Good? Okay, good. No, sometimes I teach and I can literally see people's faces light up and it's just like, nice. Okay. So, and later in the semester, there's a couple of really mind-blowing concepts that I love teaching because I literally see people go. It's fun. So, okay. So here, person Bob. It's a variable declaration. It's just like any other variable declaration, except we have defined the variable ourselves. Yeah. How do I know it's not the function person? Okay. There is. It is confusing. I totally agree with you. We have to remember this about constructors. The constructor of a class is exactly the same as the name of the class. So when we say person Bob, there are parentheses after this, right? And parentheses make something what? A function call. You're absolutely completely right. But in this case, something weird is happening, and we haven't quite seen it before. And the weird thing that's happening is that when we say person Bob, we are calling this thing the constructor right here. That builds a person for us. Because when we're creating our own little variables like this, we have to have some way of saying what happens when you create it. So person Bob right here says this thing's going to be a person. Its name is going to be Bob. And oh, by the way, call the constructor that has these 5 things in it, which is actually this one right here that sort of goes off the bottom of the screen. Are you just nodding because I've completely overwhelmed you, or do you sort of see it now? Okay. Yes. Okay. So you don't understand why underneath we have class person and we have public and we have this thing person right there? And the one underneath it? Yeah. So the weird thing about this is that these are called constructors. And what happens, and I'll show you this, like we'll go through an example because it makes a really wonderful exam question. I'll show you how these constructors actually operate. But what happens is when one of these things gets called, like person over here, like when you say person, you're instantiating, you're building something from the blueprint, this constructor happens, or the appropriate matching constructor happens to make sure things get initialized. So when we call person Bob with these values right here, the compiler goes, aha, we're creating a person. I saw that thing in the person class. So let me figure out if there's a constructor that matches this. How many different arguments are in here? How many parameters have we got? And they are what type? String, string, int, double, double. Well, the compiler goes, aha, person. This is a new class I haven't seen before. It will have a constructor. The constructor is the same name as the class. And that's bizarre. That's totally different than what we've seen, right? Let's just all admit that's bizarre. Everybody, bizarre? When you see this bizarre thing, here is what's happening. Okay? What is happening is it's calling this weird function that does stuff inside the object. So person Bob creates an object and it says, well, I have these 5 things. It matches these 5 things over here, right? So it copies the parameters from one to the other, just like a function. Yes? And then it uses these things to set the internal private portion so that when this line is finished, we have an object. It's of class person. The variable name is Bob. And inside it is Robert's age 12, who's 1.2 meters high and weighs 40 kilos. Okay? Yes? Yes. Sometimes you need many constructors. Yes, because there may be different ways that you can create the same object. So this right here is also a constructor, right? This is the constructor that happens if you don't specify anything. And it says that there's someone who happens to be 18 and we don't really know anything about them. We just put some default values in there, okay? You can have multiple constructors for the same thing. You can build the same object different ways. And it all exists to do 2 things. Make your life easier and totally baffle you. Okay? Does that make sense? So I'll work left, yes. Yes. Okay, I'm not going to talk about how to put it into different files. When you get to next class, they will teach you how to put person in one file and recess in a separate file and still have them work together. It's not hard to do. I just don't want to go into it here. Yes, for this class, everything goes in the same file, just because it's easier and I don't want to baffle you. Yeah. Mm-hmm. Good question. So here, we call Jane Doe. We don't set height and weight, so what are going to be inside those? We don't know. We don't know. Just like any other variable, if we don't set them, we don't necessarily know. So now some things that are a class, like a vector, like this vector, person, kids at play, guess what? Vector has its own constructor hidden inside of it, which is why when you create a new vector, there's nothing in it. Because it solves the constructor and says, ah, good. That's why when you create a string, has its own constructor, the string isn't just full of garbage. It's empty, right? When you create a string, like it's probably empty. So, yep, Kevin, and then I'll come back to you later. Uh-huh. No, if you wanted to do something human : : that would be an entirely different class. Because this is the person class, not the human class. You can't, the constructor has to be exactly the same name as the class. It has to be : : Yes, every constructor will be name of the class : : name of the class. Every single time. There's no way to put something else for a constructor. It actually just makes the compiler happy. And the reason is, I mean, we may not need it. Some compilers, if you don't put that in there, will make it for you. And some don't. I'm like an old person, and I always expect my compilers to be stupid. And so I do stupid things just to accommodate them that may or may not be necessary. All right. I enjoy this stuff so much. I've just been talking for 40 minutes straight, and nobody said a freaking thing about taking a break. So Well, it's been 37 minutes. So stand up, stand up. I'm glad you all are enjoying this a millionth as much as I am.
Is it wrong to think of it as like you're defining like the parameter is thinking of it in terms of function, so that like person with the string first name, that's normally what's after in main in like a function?
Yeah, that's a little wrong. I wouldn't think of it that way. So here's how I would think about it. Say you were building a house, right? And say, like, do you want a one-car garage or a two-car garage? How many bedrooms do you want? Do you want a basement and stuff like that? So we have blueprints for our house, but we can also say, hey, for this house, you know, do it a little bit different and specify things differently. So it helps you, like when you create this thing, it helps you set up what's inside the house, and it helps you pick the options that you. So, yeah, it's the kind of thing that you sort of have to, like all this stuff, you have to do it once to sort of get it. So. There's one for each of you. That was right on the spot, too. That's right where you wanted it. Oh, look out! Sorry. That's like the longest shot in the room there. Question or candy? Okay, welcome back. Questions that you thought of while we were gone? Uh? Comments as to what each file is? Okay, I will try and comment things up a little bit. So, all right, other questions? Comments? Comments about comments? All right, so let's just go back and step through this code again, okay? Where do we start? Every time. Person Bob, what does this do? Yes. It creates a person object with the variable name Bob. And what does all this stuff inside here do? It gets put inside to the matching constructor, which sets the internal private values. Okay? Everybody sort of see that? This thing is weird in the sense that it is at once a variable declaration and at the exact same time a function call, which is weird and bizarre and baffling. I totally agree. Okay. All right, so we've created Bob. That's nice. And so down here we go down, and what does this line do? Okay, it says take Bob, the object. Dot nickname is refer to the nickname of Bob, which is this string that is public, so it can be accessed directly, and set it equal to what? Okay, so Bob is what? It's an object of what class? It's an object of the person class, which means that it is an object that is instantiated from the blueprint of the type person. It has in it a public data member. A public data member, right? This is data. It's not a function. It doesn't have, it's not a method, I should say, the fancy word we use for function inside classes. It is just a string. And so when you say bob.nickname, it refers to this internal thing in here, nickname, and it sets it to sleepy. Yes, sir? We are initializing. We're initializing all the data in the class, and we're doing it right here with this stuff. Yep. Now, up here, this is the default constructor that gets called. And we can just default things. We can set defaults in here if we want. All right. And so here, this is what we call a default constructor. It's a default because it doesn't take any parameters, and it just sets some stuff. Okay. Yes, sir. If we put 3 parameters where? When we tried to create something? So we did this last time, but I'll show you again. There you go, 3 parameters. When we compile it, what will happen is the compiler will puke and die because it says, I don't know any constructor that only has 3 parameters. I only know about 2 different constructors, one that has no parameters and one that has 5 parameters, string, string, int, double, double. That's it. So you can't actually do that. Now, whoops, I've done something horrible here. Make sure I put everything back how it was. All right, well, I lost stuff. Okay, everything back to normal. So it's just like any function. The parameters have to match exactly. Okay. Now the question is, could we do default parameters like we can do for a function? Yes, we can, but let's not worry about that right now. Okay. Can what? Yes, absolutely. If we wanted to set like a nickname here. Yep, absolutely. Yeah, a method that belongs to the class can adjust any private or public stuff. Just public stuff can be changed by anything. Does that make sense? All right. So here we were. We created person. We set their nickname to Sleepy. Everybody good with that? All right. What happens down here? Person. We create another person. What's their name? Well, the variable name is Leon, but their first name is Leonard, Caprio, stuff like that. So just like we created an object of person class before that had a variable name of Bob, now we have a second one that's called Leon. Okay. Everybody with me so far? All right, now we get here to this thing called recess. Uh-oh, what is recess? It's another class, and we know that because we saw it right up here, right? Recess. It's a pretty simple class. It doesn't have a lot to it. It just has a vector, and it has some accessors and observers for the vector. Okay? Now, it just so happens that this playground, notice there are no parentheses, are there, at all? There aren't. So it's sort of like a variable. When there are no parentheses, it will call the default constructor, this one that has no parameters. And again, I can see how this is confusing, okay? So this creates a playground object. Only thing in the playground object is this private data member. There's no other data members except this private data member. What is in that vector when we create it? Nothing, because when we create a vector, it starts with nothing in it. So, all right, now we say playground. What is playground? An object of what class? And what does this dot mean? It means access. It means use one of the methods inside this particular object, and it says go to recess Bob. So what does go to recess do? It copies Bob, because it's a parameter, into this kid right there. And then kid gets pushed into the kids at play vector. So now the vector of kids that's keeping track of who's at recess has 1 kid in it. Yes? Yes, sir. Oh yes, every class has a constructor. If you don't create a default one like this, some compilers will create it for you. I do it by habit, like I said, because I'm an old man. Yep. Sorry, I couldn't hear you because people were walking by. Say it one more time. Which method? Uh-huh. Because go to recess has nothing to do with people. Mm-hmm. Yep. Well, we already said up here when we declared our class, right, we said go to recess, and we said the parameter that's going to be passed to go to recess is going to be a person, right? And when we wrote our thing down here, that was the prototype, just like we have function prototypes, we have method prototypes. This is go to recess, and it says person kid. This is just like all the other parameters we've seen for functions. So Bob down here, right, has all these different values. These values get copied into the kid object up there. Okay? And then that kid object gets pushed onto the vector that is inside the recess object. Yep. Yes, this is just a variable name. We could, whatever it is you wanted to, like anything would work as long as it was a valid variable name. But I just chose kid because that's who goes to recess. Yes? I don't know. Sure, why not? Yeah, make it work. I don't know what our autograder expects because I haven't looked specifically at the compiler on the autograder. It might create it for you and it might not. But I mean, it's like 2 lines of code, you just put it in there to be safe. Yep. Nope. The question was, are objects automatically passed as reference parameters? And the answer is no. The only way they are passed as reference parameters is if you put an ampersand in there. Yep, Sarah? Yep. Okay. So we have this class called recess. What is a class? A blueprint. How do we create an object of that class? You use recess. So this playground right here, as I said, recess is the class. Playground is the name of the object that we were creating from the recess blueprint. So just like before we had like string name, int, count, now we have recess, playground, and the playground is where kids go for recess. And so this now is in one of the object of the recess class. I can see your will to live dying. It's like wilting before my eyes. I'm really sorry. So it's a different way of thinking. It absolutely is. So. Exactly. So recess playground says make one of these objects, name it playground, and use the blueprint from recess to do that. This blueprint happens to contain a couple of methods we could call. Go to recess, go back inside, and who is at recess, right? And so now we say go to recess, Bob, and it says, okay, Bob, who we defined up there, is passed as the parameter to go to the recess for this playground object, and this playground object has inside of it a vector named kids at play. Bob gets copied into kid gets pushed back into the vector, and now this vector is inside the object. Okay? I mean, it's clear as day. I don't understand why you're not seeing it immediately. It should make perfect sense. So no, working with this stuff it's a shift and it takes a little practice. The good news about this is when you're done with project 4, you'll look back at project 3 and go, oh, project 3 was easy. Or maybe project 5, you'll say project 3 was easy, right? How many of you would like to do project 1 over again? Was it hard at the time? Kinda? How would you like to do project 2 over again? All right, like each one of these things is going to be hard the first time you see it, but once you've worked your way through it, then next time you'll be like, oh, I know how to do that. So, by the way, did I mention on the first day of class that this is a hard class? Did I bring that up at all? Yeah, I did? Okay. So, and that's fine because let me tell you, in college you want to take the hard classes. If you're taking easy classes, you're probably not learning enough. So, why would you pay all that money to do something easy, right? Okay, and don't answer that question. So I've been there myself. Okay, so playground, then we have playground who is at recess, okay? This says, for this playground object, call the method who is at recess, and it goes, okay, who is at recess? We're going to loop from 1 to kids at play at size, kids at play being the vector that holds stuff, and we're going to output the first name of everybody who's there. All right, so what else could we do with this? Could we send anybody else to recess? Who else can go to recess? All right, so let's send Leon to recess. Let's make sure I didn't screw something up. It's still sort of compiling. And look, Robert and Leonard are at recess. And I feel like an elementary school teacher being quite formal that way by saying their full names. Yep. Okay. Great. So you can't actually have it output the variable name. But if you really wanted to have like something less formal, what we would do is we would set their nicknames to Bob and Leon because we have nicknames for them. And who is at recess would output their nickname instead of their first name. Does that make sense? We don't really have to do that here. Okay, do you have to put brackets after playground but nothing in it? Where do you mean? Down here? Up here? There? No, you don't have to. You might be able to. I don't know what happens if you do that. Yeah, it's a like this is like I don't know. I'm going to make a bad analogy here. This is like the Schrodinger's cat of whether something is a variable or a function because it's like sort of both at the same time, right? It's sort of both. And it's completely baffling. I totally get it. Think of it as a function that when it comes back, it returns an object of that type. And that should clear everything up, and you should be fine now, because I said those magic words. Yeah. You just kind of take it on faith, right? Just say if I say person something, then it's going to be one of those objects. And if I put that stuff in the parentheses, then that stuff's going to be initialized. Okay. All right. Everybody sort of good so far? All right, so this is the type of stuff, and actually this is super similar to what Project 4 is going to look like, because you're going to have subjects instead of people, right? They're pretty similar. They will just have different fields. And instead of recess and having a playground, you're going to have a trial. And in the trial, there's going to be a vector of subjects who are participating in that particular trial. And so the methods and things go towards that model instead. Okay. All right, who's happy? Ooh. Yeah, no, like right now, who's happy? Who's unhappy? Who just wishes class was over and you could go outside to the farmer's market and get a pizza? Yeah, me too, sort of, sometimes. Okay. Any question? Yeah? Yeah? And I've given you a huge hint, man. I wrote like a whole example that does really similar stuff. And the stuff that I haven't written that you have to do is also really similar to Project 3, right? Like you all know how to compute averages. Oh, we'll do one more thing. How about this? How about we figure out how old the average people is at recess, okay? Okay, so we're kind of curious. We know that there are kids outside playing, and we want to figure out how old they are, okay? The average age. So we're going to create a public method, public called average recess age, because we want to be able to call this from outside. And we're going to write a little thing that computes the average of age, okay? So this is going to return a double, because it's an average. It's going to be part of the recess class. And it's going to be average recess age. All right. We have this vector up here that's full of persons. How do we tell how old a particular person is? Yep. Yep. Person has this method, getAge, right over here. And so we can call getAge on each person object and find out how old they are. How do we access each person object? For loop, exactly. So we have a for loop. It looks an awful lot like this one. So I don't really feel like typing it over again. So what do we do for each kid inside the vector? So pushback puts them into the vector. They're already there, right? We get the age. So how do we get the age for a particular person? kids at play. This for loop will start at 0. It will go up to the highest legitimate position in the vector. And if we say kids at play square bracket I, it will look in the vector and it will return the particular person object who is at that position in the vector. Okay? I just want to make sure everybody sees, like, we do this just like we accessed every other vector, right? Is this familiar to you now? You all comfortable with this? The weird thing about it is that when we get that thing, we say dot get age. And what this means is look in this vector, find the thing in that position, and then when you get that, run this get age method for that. So that will get the age. All right, what do we have to do now? How do we do an average? We need a sum. And so we just say total plus equals that. And then how do we compute the, do we need a counter? No, we don't need a counter. We just return, yep, because we have the size, total divided by kids at play dot size. Look at that. Nope, this is outside the for loop. This is the, so now we can say after, we can say who is at recess, and we can say playground what do we call that? Average recess. Any predictions on what this is going to be? All right, the average just returns the value. It doesn't output it. So for this one, we actually have to use output. For who is at recess, we actually had the output in there. So we don't need to output in there. So let's see if this works. It compiles cleanly. We run it. And we say Leonard, Robert and Leonard are there, and their average age is 12. Okay. And then, you know what? Leon has his birthday. And then the next day, what happens? They have the average recess age. What happens? How old is he going to be? And so what will the average be? What? It was still 12. Nope. Here's why. It's not a reference. So Leon right here is different than the Leon that's stored in the vector. Because the one that's stored in the vector didn't have a birthday. Because they are separate objects, right? Because when we put things into the we put things into go to recess, it is not a reference. There is a copy put in there. So if we really wanted to change Leon's birthday, we would have to go into the recess vector, look through the vector until we found Leon and call birthday there. Like the Leon here that we created is separate than the one that gets pushed onto the vector. And I know that's baffling, but that's the way it works. Pardon? I don't want to get into that. For right now, the way we know to use vectors doesn't include allowing us to have references to things in vectors. The good news is Project 5 will teach you how to do that. Sort of. You'll be on your way then. So. All right, how's everybody feeling? Good? You're such liars. All right, let's take a 1-minute break, stand up and stretch for a minute. No, it's no fun when you're looking. All right, welcome back. Did any questions spring to mind during your little break there that you need answered? Yes? Yes, you can remove things from a vector. And this is actually, when I was starting to write this class, I was kind of like, ooh, I'm going to get in trouble because I haven't actually taught you to remove things from a vector. Like, going back inside should remove things from a vector. And here's the thing, I actually don't want to have to get into how to remove things. If you look at the vector book and the textbook about vectors, there's like a remove, and you just give it like the right position, and it'll take it out of the vector. So we'll just pretend this never happened. There we go. People only ever go to recess. It's like when your dog gets old and goes. It's like when your dog gets old and goes to live on the farm and never comes back. So people only ever go to recess. I'm a cruel person. So what? All right. So, programmers are what? Being a programmer does not preclude you from being stupid. However, programmers are generally lazy. So let's talk about one thing really fast. Let's say we had a string, and we had like first equals Bob. And we had a string second equals Roberts. How could we join those together? So we could do first dot append second. That would work, right? What else could we do? First plus equals second. What is the difference between this first one, first dot append, and first plus equals? Functionally, there is no difference between the two. Functionally. Which one is easier for you to look at and read as a programmer? How many of y'all think the first one is better, easier to read? How many of y'all think the second one is? Really, the first one? The second one's way easier to read, in my mind, right? Because you just look and you go first, okay, plus equals second. This one you're like first, oh, they're calling a method and what's going in there. It's a little trouble. So, one of the things programmers do to make their code readable is they put these operators into place. Now, what is a string? Like literally, what is a string? It's a type. Is it a type? Or is it something else? It's a class. There's a string class, and this string instantiates one thing of that class. So here when we do plus equal, what are we doing? Are we adding these classes together? How do you think you know how to add classes together? Yeah, like if we have a string and it's a bunch of letters, right, and it's a class. With me so far? Let's step back. How do we know how to add two numbers together? We just add them, right? Like the plus sign means add. There's a whole bunch of dedicated computer circuitry in there that adds numbers like incredibly fast. So that's easy, right? Because those are numbers. But what is a string? It's a class. It's made out of one of these blueprints. But somehow we're able to use plus equal on that. Does that not strike you as a little bit strange? Unexpected? Unusual? No? You're all just willing to take it on faith? Yeah, but int we know because that's numbers. Like, what does it mean to add a string? Like, is there some natural thing that string addition means that we all agree on? I did. In this case, it's concatenating. But how does the compiler actually know what to do for this case? It is kind of like a function, isn't it? In fact, it's really similar to this function right above it, isn't it? Like, don't they do the same thing? What's changed between this and that? The notation. That's it, right? First dot append and first plus equal second do exactly the same thing, but what's changed? The notation. The way you're doing it internally may not be different, but the way you're writing the code may be different. So let's say we wanted to do something for playground. What? I love it. I wish I had that recorded. That would be great. All right. So playground, go to recess Bob. We're sending Bob to join people on the playground. Aren't we? Isn't that what that first line does? What does this second line do? It adds Bob to the playground. We send Bob out to the playground. We just like we did this with string up here, and we did plus equal, why can't we do the same thing down there with sending Bob to the playground? What do you mean you can't? We do it with strings. Don't we do it with strings? How does it know that's what it means? Exactly, that's the question I'm asking. For a string, how does it know what plus equal means? Somebody put it in the string class, absolutely. So how about plus equal here for the playground class? We didn't add that. I've got an idea. Why don't we add that? Why don't we make it so that our operators, like plus or plus equal, work for our playground class? And then when we send kids to recess, we can use plus equal instead of saying dot go to recess. Everybody with me on this? Yes? So both of these things are going to do exactly the same thing. It's just that they're going to do them in different ways. Different ways that we type so that we can have different options when we code. Yes? Uh-huh. Okay. Well, string has other things too, right? String has append, it has length. We have all sorts of stuff. Like, why doesn't first plus equal second not add the length of the second string to the length? You're not seeing it? So you get first dot append second, right? Then why doesn't playground make sense? They're the exact same thing. They are literally exactly the same thing. Look, we're appending the second string to the first. We're sticking Bob in the playground vector. That's what append, we could change this and make this append. Okay, so here's what I'm trying to show you. C++ will allow you, if you want, instead of having to use these method names to define operators, and by operators I mean like plus, equal, slash, whatever you choose, in fact, to mean things in terms of your class that you're developing. In this case, what I am proposing is that we make plus equal for the playground be the same as go to recess. So if you say playground plus equal one of the things, that thing will be added to the vector. How many of you all think that would be a nice way of doing it, notation-wise? Yeah, some of you are just like, I feel like I'm pressuring you into something, right? I'm not. It's just, this is kind of easier to understand than go to recess. So we don't have time to get into it today, but now that I've given you this introduction, when we start class next time, this is what we will look at. And we will look at how we can do overloaded operators. In the past, we talked about overloaded functions. Do you all remember overloaded functions? What is an overloaded function? Yep. Different types, right. An overloaded function is a function that has the same name, but it has different types. An overloaded operator is an operator like this that has some meaning, but it has a particular meaning for different classes. Like each class can say, hey, when you use this operator to refer to me, this is what I mean. And we're going to look at how to put that inside the class definition so that when you write classes, you can do neat things like that. Okay? That is not part of the project. It's just fun. So for very geeky and horrible definitions of fun. Any questions before we part today? I will go back to my office and make sure all the Project 4 stuff is posted so you can look at it. I've given you like 90% of the answer already. So have a good weekend.